Absolute continuous positioning systems are the most common type of Magnettrack positioning system. Absolute positioning systems obtain a start coordinate after turning on the system at any point on the track. Position marker is a single permanent magnet in a protective shield. Here are the general benefits of absolute Magnettrack system based on position markers. Easy installation of magnetic marking elements according to a template or almost free. The absolute accuracy of the system does not depend on the accuracy of mounting position markers. Thanks to the super adaptive positioning core, the real coordinates of installed markers are calculated automatically with a high accuracy. Possibility of markers installation with significant possible mounting tolerances to keep the system absolute. Minimal emergency repair kit, since all track markings are the same and interchangeable. Fault tolerance, the degree of which depends on the specific marker's trace. Low price. There are three types of absolute Magnettrack system based on position markers depending on how the position markers are installed on the trace. 2+1. In 2+1 systems, a minimum of 2 magnets are present under the sensor at any point on the track. Unique distance between the neighbor magnets makes enabling absolute coding of the whole positioning distance. At the moment of changing the magnetic pairs, 3 magnets are present simultaneously within the limits of sensor working area. 2+1 systems have the following features. Minimum number of installed magnets for absolute positioning type. Easy installation of positioning markers according to the template. Fault tolerance in the event of failure of up to a half of the magnets in the marking before the power is turned off. In practice, 2+1 systems are used for positioning at distances of up to 200 meters. The tolerance for the installation of markers, as a rule, does not exceed ±10 mm. Lowest possible price. 3+1. In 3+1 systems, at any point on the track, at least 3 magnets are simultaneously presented under the sensor, and when changing the adjacent of magnets, there can be up to 4 magnets simultaneously presented under the sensor. In systems of this type, absolute trace coding is achieved by a consistent pair of distances between 3 adjacent magnets. Systems of this type have the following advantages. Increased fault tolerance. 3+1 systems are capable of functioning in the event of failure of up to 2/3 of the trace markings until the power is turned off. Almost unlimited absolute positioning distance. It is possible to build 3+1 tracks for distances of several thousand kilometers. 3+1 systems have an increased tolerance for mounting markers, as a rule, several tens of millimeters. Almost free way of mounting markers. Absolute systems with almost free mounting of positional markers are the pinnacle of the development the idea of adaptive positioning. The super adaptive core allows placing position markers along the track almost free, observing only 2 conditions. At any point on the track, under the sensor there must be at least 2 magnets, and there must be no duplicate magnetic signatures. Both of these rules are easiest to follow when installing a system using motion control technology, controlling the installation using the super adaptive core itself. This way of placing markers is recommended in systems where the positioning distance is relatively short. It is possible to install the sensor of sufficient length and maximum flexibility in the mounting of markers is required. But the absence of a predefined markers coordinates table may require more installation effort to maintain the absolute type of the system than installing systems according to the 2+1 or 3+1 schemes discussed earlier.